Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is solutions and concentration terms, molarity, molality and normality. Understanding these concepts is essential for solving numerical problems and developing a strong foundation in physical chemistry. So, let's dive right into it. To begin with, let's talk about solutions. A solution is a homogeneous mixture of two or more substances where the solute dissolves in the solvent. For example, when salt dissolves in water, salt is the solute and water is the solvent. The amount of solute dissolved in a given quantity of solvent determines the concentration of the solution. Different concentration terms are used to express the amount of solute in the solution, and the most commonly used terms include molarity, molality, and normality. Let's first discuss molarity, which is one of the most widely used terms in chemistry. Molarity refers to the number of moles of solute dissolved in 1 liter of solution. It is denoted by the symbol m. Since molarity is based on volume, it can vary with temperature because the volume of the solution changes with temperature. Molarity is extremely useful in chemical reactions where reactants and products are in solution form, especially in titrations and stoichiometric calculations. Next, we move on to molality, another important term used to express the concentration of a solution. Molality is defined as the number of moles of solute dissolved in 1 kilogram of solvent. It is represented by the symbol m. Unlike molarity, molality is independent of temperature because it is based on the mass of the solvent, which remains unaffected by temperature changes. Molality is often preferred in situations where temperature variations are involved, especially in colligative properties such as boiling point elevation and freezing point depression. Now, let's discuss normality, which is a slightly different concept but equally important. Normality refers to the number of gram equivalents of solute present in 1 liter of solution. It is represented by the symbol N. A gram equivalent is defined based on the type of reaction involved. For acids, it is the mass of the acid that furnishes 1 mole of hydrogen ions, and for bases, it is the mass that furnishes 1 mole of hydroxide ions. Normality is commonly used in acid-base titrations and redox reactions, where the concept of equivalence plays a vital role. Understanding these three concentration terms not only helps in solving problems but also gives insight into how different types of solutions behave under different conditions. For instance, molarity is useful when dealing with reactions in aqueous solutions, while molality becomes essential in studying the effect of temperature on solutions. On the other hand, normality simplifies complex titration calculations by directly relating to the number of reacting species. It's important to note that converting between these terms may be required in certain situations. For example, if the density of the solution is known, molarity can be converted to molality and vice versa. Similarly, normality can be related to molarity if the equivalent factor is known. To put these concepts into perspective, think about preparing a saline solution in the lab. If you dissolve a certain amount of sodium chloride in water and measure its concentration based on the volume of the solution, you are calculating molarity. But if you measure the same amount of sodium chloride with respect to the mass of water used, you are calculating molality. And if you are considering the equivalent amount of sodium chloride that reacts in a chemical reaction, you are dealing with normality. Molality, on the other hand, measures the number of moles of solute per kilogram of solvent. Unlike molarity, molality is independent of temperature because it is based on mass rather than volume. This makes molality a more reliable unit when dealing with temperature-sensitive reactions, such as colligative properties, which include boiling point elevation and freezing point depression. Since mass remains constant irrespective of temperature changes, molality provides a stable measure of concentration in various practical applications. Normality is another important way to express the concentration of a solution. It represents the number of gram equivalents of solute per liter of solution. The concept of normality is particularly useful in acid-base reactions and redox reactions, where the reactive capacity of a substance is essential. Normality accounts for the number of reactive units in a solution, making it a valuable measure in titration experiments and industrial applications where precise calculations are necessary. Each of these concentration terms has specific applications and advantages, depending on the nature of the solution and the experiment being conducted. In acid-base chemistry, normality is commonly used because it directly correlates with the number of replaceable hydrogen or hydroxide ions in a reaction. In colligative properties, where freezing point depression and boiling point elevation are studied, molality is preferred due to its temperature-independent nature. Molarity, however, is widely used in general laboratory calculations, making it an essential concept in chemistry. These concentration terms play a crucial role in various applications, ranging from pharmaceuticals to industrial processes. In pharmaceuticals, accurate concentrations ensure the correct dosage of medicines, while in industries, maintaining the right concentration ensures that chemical processes proceed efficiently. By now, you should have a clear understanding of the differences between molarity, molality, and normality, and how they are applied in different scenarios. Mastering these concepts is essential for solving numerical problems in competitive exams like NEET and JEE. That's it for today's session on solutions and concentration terms. I hope this detailed explanation has clarified your doubts and boosted your confidence. Don't forget to like, share, and subscribe to AskPrep for more such insightful videos on chemistry. Keep practicing and stay curious. See you in the next video. Thank you. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.